Hey guys, this is a video for 3-5 evaluating expressions, algebraic expressions. And right here we have number 18 from our book, page 155. And it says evaluate each expression for when x equals 1.8, x equals 5, and x equals 6.4. So in the blue, we have our algebraic expression here, so x divided by 4. So because we have our x value, that means whenever I see an x, I'm going to plug in this value. So essentially, I'm doing the problem 3 separate times. So I'm going to start with this first one, x equals 1.8. So wherever I see an x, I'm going to put 1.8. So I have 1.8 divided by 4. Okay? And now I'm just going to go ahead and solve that. I've substituted my variable in, so I'm just going to solve. 1.8 divided by 4. And with decimals, you have your dividend here. You're just going to pop your decimal right up top and pretend like it's not even there. So now we're going to look at 4 goes into 18 how many times? Well, 4 goes into 18 4 times. Not quite 18, so we have a remainder of 2. Now, because I already have a decimal point here, I can annex as many zeros as I want. So I can see I don't have any more in the dividend to go, but I can annex a 0 down here. So now it becomes 20 divided by 4. So 4 can go into 20 5 times evenly. And so we would have our expression equal out to 45 hundredths. Okay, so that's that first one. The second one I'm going to do in red. So we have x divided by 4. So now we're going to look at this one. X equals 5. So 5 divided by 4. Same thing. We're going to say 5 divided by 4. Okay. So 4 goes into 5 one time, not evenly, so we'll have some left over. And if I don't have any more on my dividend to pull down, I can place a 0 and then annex as many zeros as I need. Okay, place my decimal there. Whoop. Now, how many times does 4 go into 10? 2 times, not evenly, so I have some left over. Again, I can't pull anything down, but I have put a decimal point here so I can annex zeros. Can 4 go evenly into 20? Yes, it can. And we're done with that one. So that one is going to be 0.125. So these ones were decimals divided by a whole number. And this next one, it's going to kind of be the same type of deal. I'm going to do that in purple, this last one. So we have x divided by 4. In this case, x is 6.4, so we'll 6.4 divided by 4. Okay? Now when we read it to ourselves, we say 6.4 divided by 4. Place your decimal up at the top, just pop it right up into the quotient, and then pretend like it's not there. Can 4 go into 6? Yes, one time. Bring down your next value. 4 goes into 24 6 times. Evenly, so we're done, and this one becomes 1.6. So for number 18, I should have 3 separate answers. Okay. So for number 20, we have the same type of thing, but you can see here we have just a numerical value, and then here we have a coefficient. So I have a number multiplied by a variable. So when I plug in this variable, I'm going to need to multiply these two. So I'm only going to do one example here. We'll do 6.4. So 2 times 6.4, because we're plugging this in, okay, plus 3.1. And we'll follow the order of operations. We need to multiply first, so 2 times 6.4. Okay, and that is 8 and 12. Place your decimal. So we would have 12.8 plus 3.1. And we just add those together. Bring down your decimal. Whee! super doable. So when we have that substitution 2x plus 3.1, you're going to put a little parenthesis right here. And wherever there was an x, you're just going to put that value in to solve for. And then because this is a coefficient, so it's a number multiplied into a variable, you're multiplying these two. Okay. And then finally, this last problem, this one's number 21. The layout of this kind of got kids confused, so I figured I would just show you. We have a semicolon here. You don't have to worry about this piece of punctuation. Really all it's doing, we can just pretend it's not even there. It's just separating the two. So our algebraic expression is j plus 3/8. And then wherever we see a j, we're going to plug in 3/4. So let's try that. 3/4 plus 3/8. And then I need to remember my rules about adding fractions. Can't really add a fraction with different denominators, so I know that a 4 can be made to look like an 8. So I'm going to do that up here. We're going to have 3/4 times something to make it an 1/8. So 4 times what equals 8? 2. Whatever I do to the denominator, I need to do to the numerator. So 3 times 2 would be 6. So an equivalent fraction to 3/4 would be 6/8. So I can just go ahead and pop that in. So this becomes 6/8 plus 3/8. And now they're friendly and we can add them together. So this stays 8 and it becomes 11/8. This is fine to leave it as an improper fraction, but if we wanted to, we could change it into a mixed number. So I know that 8/8 is 1 whole, and then I have 3/8 left, so it would be 1. Oh, sorry. What did I do here? 6 and 3 is 9. Oh! I was like, that's not right. Okay, let's do this. I don't know where I got 11. Okay, so this is 9/8. So then we would have 8/8, which is 1, and 1/8 left over, so it would be 1 and 1/8. My apologies, guys. Okay, so really the skill that we're practicing is plugging this number into where you see a variable. The part that I'm seeing struggle with are these skills that we've already practiced, like multiplication of fractions or division of fractions or decimals. Okay, so if you need to, remember we do have help videos for those practicing skills of dividing with decimals if you need it. I hope this was helpful. You guys have a great afternoon.